Assalamualaikum and a very good day to everyone. So today we would like to present our project titled Water Balloon Parachute Plunge. So my team members are ALIF DANIAL, ARIEF HAIKAL, Nur Alisha Irdina, Nur Afrina and myself ILHAM AWATIF. Before we begin, let me explain the introduction. So this project focuses on understanding motion during free fall and the effect of air resistance. In real life, objects do not fall freely because air resistance slows them down. A parachute is a great example of how air resistance can be used for safety. So, through this project, we can connect physics concepts to real-life applications. The main physics concepts in these experiments are free fall, gravity, air resistance, work, and kinetic energy. During free fall, an object moves only because of gravity, but when the parachute opens, air resistance increases and slows the object down. This demonstrates how forces influence motion and energy. For problem statement, the first one is students often face difficulties visualizing free fall and air resistance. The second one is physics is sometimes taught to theoretically without enough hands-on experiments. Next, we have 4 objectives. So the first one is to investigate the motion of a falling object with and without a parachute. The second one is to observe how air resistance affects falling speed. The third one is to compare the falling time between free fall and the parachute motion. And the last one is to relate the experimental observation to physics concepts. For significance of project, this experiment helps students to understand physics through real observation. It also increases learning interest through a fun activity, and then to improve scientific skills like measuring and analyzing data. And the last one is to apply physics knowledge in real life situations such as parachute safety. Next, we move to how we can conduct the experiment. So the first one is we can prepare a simple parachute using plastic, strings and a small weight, and then we can drop the object without the parachute and recorded the falling time. Next, we can also drop the same object with the parachute from the same height. Next, we can observe and compare the difference in falling speed and time. Finally, we analyze the results to understand the effects of air resistance.
Next, I will explain about the flowchart of the experiment project. The flowchart begins with project briefing, where the objectives, safety guidelines, and basic concept were explained. This is followed by experiment 1 to observe the freefall motion of the water balloon. The problem was identified when the balloon burst due to excessive impact force. A parachute was then designed and built using physics principles. Experiment 2 was conducted using the parachute, and the collected data were analyzed using tracking software. Finally, the results were presented using graphs and diagrams. Next, I will explain about the parachute design. The parachute has a small hole in the middle with diameter of 0.5 cm. This hole helps air pass through and keeps the parachute stable during falling. The canopy is circular and made from a thin trash bag with a radius of 40 cm. The large surface area increases air resistance and slows down the fall. There are 16 strings made of thin thread, and each string is 66 cm long. All strings are the same length to keep the parachute balanced. A circular sponge is placed at the bottom. It helps to reduce the impact force and allows a softer landing. A plastic ball with a radius of 15 cm is used to hold the water balloon. This keeps the balloon stable and protected during the drop. Next, we are going to the procedures of experiment 1, which is free fall. For experiment 1, the mass of the water balloons was measured and kept consistent before being dropped from the second, third and fourth floors of the building. The height of each floor was measured using a laser meter and marked clearly. The water balloons were then released from each height, and their motion was recorded using video to measure the falling time. The horizontal distance from the landing point was also measured. Each step was repeated several times to ensure accuracy, and all data were recorded in the tables provided. Next, procedures of experiment 2, which is with parachute. In experiment 2, a new parachute prototype was built to reduce the impact force on the water balloon. Steps from experiment 1 were repeated using the new prototype. All observations and data were recorded within 30 minutes. If a water balloon broke, it was replaced with another balloon of nearly the same mass. The data collected were then compared with experiment 1 to observe differences in potential energy, kinetic energy, and impact force. Next, the summary of result of dropping balloon without parachute. When the balloon was dropped without the parachute, it fell much faster. The time taken was shorter and there was little air resistance. The velocity and kinetic energy were higher, causing a strong impact. The balloon broke easily when it hit the ground. And the results of dropping balloon with parachute. When the balloon was dropped with a parachute, it fell more slowly. The time taken to reach the ground increased because air resistance acted on the parachute. The velocity and kinetic energy were lower, which is reduced the impact force. The balloon did not break or had less damage, showing better protection.
Okay, now I will talk about kinetic energy versus time graph. First, we look at kinetic energy versus time graph. This graph basically tell us how much kinetic energy the balloon has just done before it hit the ground. When we drop the balloon without a parachute, the kinetic energy spiked massively. From the 4th floor, it hit a height of 14.67 joule in just 1.3 seconds because there was almost no air resistance. Potential energy convert directly into high speed. This is why the balloon burst when it hit the ground, because it has too much energy. Next, we look at the difference when the balloon has a parachute. From the same floor, which is the 4th floor, the kinetic energy was 1.44 joules. Was only 1.44 joules, which is roughly 10 times lesser than the energy than with a parachute upon impact. And the fall time also extended to 3.7 seconds. So in conclusion, the parachute successfully create air resistance to limit the terminal velocity, ensuring a soft landing. Next, we look at potential versus graph energy. This graph track the energy stored in balloon simply because of its height. In both scenario, which is without parachute and with parachute, the potential energy start at height. For example, about 38 joules from the 4th floor and drop to 0 when it hits the ground. Okay, without the parachute, the line is steep. The energy drains is less than a second. With the parachute, the slope is much more gradual. It took nearly 4 seconds to deplete the potential energy. This shows us that instead of all the potential energy turning into dangerous speed, the parachute forced the system to do works against air resistance, spending that energy slowly over time. Okay, next is acceleration versus time energy graph. Okay, without the parachute, our data showed a constant acceleration of approximately 9.81 meter per second square. This confirmed the balloon was in free fall, influenced almost entirely by gravity. But with parachute, the physics changed completely. We record acceleration of 3.98, 1.8, and as low as 1.13 meter per second square from the highest floor. Why is this happening? It is because of Newton's second law. The parachute create an upward drag force that fight against gravity as the balloon fall. The increase and that drag increase, cancelling out gravity drastically, lowering the net acceleration, which allow the balloon to stabilize rather than speeding up uncontrollably.
In these sections, I will present the result obtained using the tracker software without a parachute. So the experiment was conducted by dropping a balloon from the different floor heads, which are second, third, and fourth floor. This graph analyzed include kinetic energy versus time, potential energy versus time, and accelerations versus time. So for the second floor, the drop head is 5.05 meters and the mass of the balloon is 0.246 kilograms. For the kinetic energy time graph, we can observe that the kinetic energy increase as time increase. This indicates that the balloon gains speed as it falls. So meanwhile, the potential energy time graph show a decreased trend, which means the potential energy is converted into kinetic energy. The acceleration time graph show an almost constant value, which is consistent with the effect of gravity. Okay, next, for the third floor, the head increases to 9.16 meters with a balloon mass of 0.200 kilograms. The overall pattern of the graphs is similar to that of the second floor. However, the increases in kinetic energy is more significant due to a greater head. So this shows that a higher drop head results in greater kinetic energy. Okay, for the fourth floor, the drop head is 13.03 meters and the balloon mass is 0.293 kilograms. The kinetic energy time graph shows a larger increase compared to the lower floor. The potential energy is also higher at the beginning of the motion due to the greater head. The accelerations remain nearly constant, indicating free fall motions with minimal air resistance. Okay, in this part, I will discuss the result obtained when a parachute is used. The purpose of using a parachute is to study the effect of air resistance on the motions of the balloons. The same floor head we are used for comparison. Okay, for the second floor with a parachute, the drop is 5.09 meters and the balloon mass is 0.274 kilograms. The kinetic energy increase more slowly compared to the case without a parachute. This is because the air resistance reduced the falling speed of the balloon. The acceleration time graph show more variations, indicating the influence of air resistance. Okay, for the third floor, the head is 9.06 meters and the balloon mass is 0.283 kilograms. The kinetic energy time graph show a more controlled increase. This demonstrates that the parachute effectively reduced the balloon speed during the fall. Okay, finally, the fourth floor, the drop head is 12.31 meters and the balloon mass is 0.260 kilograms. Despite the higher head, the kinetic energy increased gradually. This clearly shows the effect of air resistance from the parachute in controlling the balloon's velocities and acceleration.
So how did we obtain the results using the tracker software? So firstly, we open the tracker software, then we choose the video that we have recorded during the experiment. So this is our first experiment, which we use second floor to drop the balloon without the parachute. So first we put the video into the tracker by uploading it. Then I set the height by calibration stick and I drag it to the first floor and I set the length. So at here I put the length of our first experiment. So it is 5.05 meter. So next we put axis and we put point of mass. So I set here the mass of the balloons that we used. So here I put 0.246 kilogram. And next what we are going to do is zoom in the video and on the balloon hold shift and left click on your mouse to track the balloon. So frame by frame, we track the balloon by using the method shift and left click until it dropped onto the first floor. Then on the right side, we chose the kinetic energy against time graph, potential energy against time graph, and acceleration against time graph. Okay, so here is KE versus T, then acceleration Y component over T against T, and lastly, the potential energy is not given in this. software tracker. So we need to put it manually. So here we put data function, name we put PE, which is potential energy. Then the expression we put M asterisk 9.81 asterisk Y and G H, the formula of PE. So G we can't use G because it can't detect the gravitational acceleration. So we put the number here 9.81. Then we confirm and we use it to find the graph of PE against time. So the comparison between the module, which we used manual calculation to sketch the graph, and this tracker software. First, the graph obtained using tracker software and by sketching video, and by sketching into in the module has overall similar trends but different in terms of accuracy and smoothness. Okay, the tracker software provided more detailed continuous data for position, velocity, acceleration, and energy, resulting in graph that better reflected the real motion of the falling object. Manual calculations relied on measured time intervals and estimated values, which we have written in the tables before, and which introduced a larger uncertainties. And as a result, manual graphs were less smooth and showed more noticeable fluctuation, especially in acceleration and kinetic energy. Despite these differences, both methods confirm the same physical concepts, which kinetic energy increases as the object falls, potential energy decreases with height, and falling time increases when approach is used. And therefore, tracker software was found to be more accurate and reliable, while manual calculations were used for reinforcing understanding of basic physics principles. So we have come into a conclusion. Through this project, we gain a deeper understanding of free fall motion and the effect of air resistance on a falling object. At the beginning, free fall was often assumed to involve only gravity. However, after conducting the experiment, we realized that air resistance plays a very important role in real-life motion, especially when a parachute is used. The results clearly showed that attaching a parachute significantly increased the falling time and reduced the acceleration of the object. This helped us understand why objects in real life do not always fall at the same rate, even when released from the same height. Observing the differences in motion from different floors also allowed us to relate height, time, and energy changes more meaningfully. Overall, the project enhanced our problem-solving skills, improved our understanding of physics concepts, and showed us how physics is applied in real-life situations such as parachute safety systems. It also encourages us to think more critically and reflect on how theory and experiment are closely connected in science.